Welcome back. In this lesson, we learn the Black Model, an extension of the BSM model for the valuation of options with derivatives as underlying. We'll learn to apply the Black Model on options on forwards and futures, interest rate options, and swaptions. A bit of a warning here, this is one of the harder lessons, but we will try to simplify things as we go along. Let's get started. In our last lesson, we learned the BSM model to value options on stocks that do not pay dividends. With some modification, the model can be used on options where the underlying is itself a derivative. For forwards and futures, we've learned that the no arbitrage forward price is the spot price compounded by the risk-free rate. The spot price must therefore be the forward price discounted by the risk-free rate. We apply continuous compounding and discounting in this case, so the spot price term in the BSM model can be replaced with the discounted forward price term. For D1 and D2, we drop the R here and replace the spot price with the forward price. Again, this is for your reference and you do not need to know the derivation of D1 and D2. You'll likely be given ND1 and ND2 if they are needed. And that's it. This is the Black Model for the valuation of options on forwards and futures. Just that for futures, the model ignores issues like margin requirements and marking to market. Likewise, we can look at it from the replication perspective, this time with a futures component and a bond component. The call option can be replicated with a long futures position, adjusted by ND1, and a short zero coupon bond position, adjusted by ND2. The put option can be replicated with a long bond position, adjusted by N-D2, and a short futures position, adjusted by N-D1. And lastly, you may sometimes see the equations rearranged and presented in this simpler form. So you may see the call value as the present value of the difference between the adjusted futures price and the adjusted exercise price, and the put value as the PV of the reverse. Let's jump into the example. The Megaland stock index is currently at 25,000. A futures contract on the MLI that expires in half a year is trading at 25,505. Suppose a call option on the futures contract has a strike price of 26,000. Given a risk-free rate of 4% and estimate of ND1 is 0.552 and estimate of ND2 is 0.498, estimate the value of the call option using the Black Model. Pause the video now and work out your answer. And we're back. The Black Model states that the value of call option on a futures contract is the PV of the adjusted futures price minus the PV of the adjusted strike price. What's important here is that you use the correct figures. We want the futures price, not the spot price. And given that the strike price is 26,000, plug in all the relevant figures, we get 1,108 points. Our second application of the Black Model for this lesson is to value interest rate options. Interest rate options are options on forward rates or options with reference FRA rates as underlying. To help us understand interest rate options, let's revisit an earlier lesson on the pricing and valuation of FRAs. If you recall, we've learned to calculate the price of a 1/4 FRA, which is the forward rate of a 90-day loan, which begins 30 days from today. We've determined the forward rate is 3.82% annualized rate. This is the price of the FRA, which we will reference here as the FRA rate. The FRA rate can fluctuate like any other asset over the life of the FRA, with changes in the spot rate, and will converge to the spot rate at expiration. An option that references that FRA price as the underlying will have a specified strike rate. If the FRA rate at expiration is greater than the strike rate, a call option will expire in the money and a put option will expire out of the money. So, as you can see, an interest rate option is consistent with other types of options. The long call benefits when the FRA rate increases, that is, when interest rate increases. Likewise, the long put benefits when the FRA price decreases, that is, when interest rate decreases. Since an FRA can be regarded as a forward contract, the Black Model can be used to value interest rate options with some adaptation. The forward price is simply the FRA rate, and the strike price is the strike rate. As these are interest rates, we multiply them by the notional principal of the FRA. Also, these are annualized rates, so we should multiply it by the accrual period to unannualize the rates. For an FRA, the accrual period is the period of the loan. Here is where it gets muddy. We've learned that FRAs and loan contracts based on LIBOR follow the 360-day count convention. However, options tend to follow the actual 365-day count convention. So if the actual number of days is 91, The accrual period in this case would be 91 over 365. Another important distinction to consider is the discount period T, which is not that straightforward. An option on the FRA should expire together with the expiry of the underlying FRA. However, we note that this interest amount we calculate is actually to be paid at the end of the loan, not at the expiry of the FRA. The discount period should therefore include the loan period. Again, the day count convention is the actual 365, so if this discount period is 123 days, we'll need to discount this amount by 123 days using the continuously compounded risk-free rate. For your sanity, we shall not discuss D1 and D2. If you ever need them in the exam, you will likely be given ND1 and ND2. The continuously compounding risk-free rate is the 120-day LIBOR rate of 3.5%. Now, such complex calculations for the option values are unlikely in the exam, but just for completion, we have all the necessary parameters for us to make the calculations. Plug in the appropriate figures into the equation for the call option, and you should get a call value of $4.72 for the call option. Again, we emphasize that this is really for your reference, so don't worry if you can't get the calculation. What's important is that you understand the underlying concepts of an interest rate option and the appropriate figures to use in the calculation. We shall have some practice at the end of the lesson. Essentially, an interest rate call allows the long to receive a payoff if the interest rate ends above the strike rate. An interest rate put allows the long to receive a payoff if the interest rate ends below the strike rate. Interesting combinations of interest rate options can be used to replicate payoffs of other contracts. For example, the pay fixed receive floating side of an FRA can be replicated with long interest rate call and a short interest rate put. That is, he pays the shortfall when the strike rate is greater than the spot rate. The strike rate of both options should be equal to the fixed rate of the FRA. If you look at it, the fixed rate payer should receive compensation when interest rate is above the fixed rate and pays off excess when the interest rate is below. So he effectively pays a fixed rate for the upcoming loan. The reverse of this, that is to short interest rate call and long interest rate put, replicates a short FRA position, that is the pay floating and receive fixed side of the contract. An interest rate cap is a derivative in which the buyer receives payments at the end of each period, an amount in which the interest rate exceeds the strike rate. Borrowers typically use this to hedge the interest payments on a floating rate loan. When interest rates are high, payoffs from the IR cap can be used to offset the higher interest payments. An interest rate cap can be replicated with a series of interest rate call options with different maturities and the same exercise price. Each of the call options in an interest rate cap is known as a caplet. Likewise, an interest rate floor is the opposite of the cap, where the buyer receives a payment for the amount in which the interest rate is below the strike rate. Investors typically use this to hedge the interest receipts on a floating rate bond. When interest rate is low, the payoff from the IR floor can be used to supplement the shortfall. The IR floor can be replicated with a series of interest rate put options with the same exercise rate. Each of these puts is known as a floorlet. For a portfolio that is long an interest rate floor and short an interest rate cap with the same strike rate, the equivalent derivative is the pay floating receive fixed position of an interest rate swap. The swap fixed rate is equal to the strike rate of the cap and floors. To understand why this is the receive fixed leg, consider a swap with a fixed rate of 3%. If the spot rate is 5%, the floating rate receiver would have to pay 2% to the counterparty, such that he only receives the fixed rate of 3%. Similarly, a long cap and short floor can be used to replicate the position of a fixed rate payer in an interest rate swap. In this case, the receive fixed party should receive 2% as compensation, as he should only pay 3% on a loan, not 5%. And if the exercise rate on a floor and a cap are set equal to a market swap fixed rate, the value of the cap will be equal to the value of the floor. Our third application of the Black model for this lesson is to value swaptions. A swaption is an option that gives the holder the right to enter into an interest rate swap in the future at rates that are determined at the initiation of the swaption. A payer swaption gives the holder the right to enter into the swap at some date in the future at a predetermined rate as the fixed rate payer. As interest rates increase, the payer swaption becomes more valuable as the right to take the pay fixed side of a swap becomes more valuable. At expiration, the holder of a payer swaption would exercise it and enter into the swap if the market rate is greater than the exercise rate at expiration. Conversely, a receiver swaption gives the holder the right to enter into a swap at some date in the future as the fixed-rate receiver. That is, it is the floating-rate payer. As interest rates decrease, the right to be the fixed-rate receiver becomes more valuable. If the market rate for swaps is lower than the fixed rate of the underlying swap at expiration, the holder of the receiver swaption will exercise the swaption. As with interest rate options, the Black model can be adapted to value swaptions. The value of the payer swaption is equivalent to a long call position, and the value of the receiver swaption is equivalent to that of a long put. An easy way to remember is that the fixed payer benefits when interest rate increases, so its position is like that of a long interest rate call. Conversely, a fixed receiver benefits when interest rate decreases, so its position is like that of a long interest rate put. We replace the forward price with the swap fixed rate, and the exercise price is the exercise rate of the swaption. Like for interest rate options, these are annualized rates. We should multiply the rates by the notional principal to get the amounts, and to unannualize, we multiply the rates by the accrual period. The accrual period for a swap is calculated by 1 divided by the number of settlement periods per year. A swaption is equivalent to an option on a series of cash flows, like an annuity, one for each settlement date of the underlying swap. The discounting of all the cash flows can be handled by one single term, that is, the present value of an annuity, or PVA. As such, the discount term on the Black model can be replaced with the PVA. And there you have it, the Black model of the valuation of a long payer swaption and long receiver swaption. Let's end this lesson with some practice. We'll start with an interest rate option. An interest rate call option on an underlying 2x3 FRA is to be initiated on the 1st of March. Given the following data, fill in the appropriate parameters for the Black model to value the call option. Pause the video now and work out your answer. And we're back. We're told that the 2x3 FRA is initiated on the 1st of March. This means the FRA will expire in 2 months, and the loan is a 1-month loan which commences right after the FRA expires. The loan should start on 1st of May and expire on 31st of May. The interest rate call should initiate and expire at the same times as the FRA. The FRA rate at initiation is the forward rate that should apply to the loan period. It should be the F21 rate. The FRA rate for the Black model is therefore 3.5%. The accrual period is the period of the loan, which in this case is 31 days, as there are 31 days in May. Remember, we used the actual 365 convention, so AP is 31 over 365. And the interest payment should be discounted all the way till today, which covers all 3 months. This is 92 actual days divided by 365. Next, let's practice on swaptions. A 3-year quarterly plain vanilla interest rate swap is to be initiated 6 months from today, with a fixed rate of 4.2%. An investor longs a receiver swaption today with a strike rate of 4.0% on the swap. The market swap fixed rate for equivalent swaps that initiate today is 4.5%. Fill in the blanks and determine the appropriate parameters for the Black model to value the receiver swaption. Pause the video now and work out your answer. And we're back. Remember, we mentioned the fixed rate receiver benefits when interest rates decreases, so its position is similar to a long interest rate put. A put payoff is exercise rate minus spot rate, so this term should be exercise rate, and this term is the swap fixed rate. The corresponding coefficients should be n minus d2 and n minus d1, respectively. The important part of this question is to understand what should the swap fixed rate be to value the swaption. This should be 4.2%, the fixed rate that will apply to the underlying swap itself, which starts at a future date. We do not use the current swap rate of 4.5% as it applies to swaps that are initiated today. The accrual period for a swap is 1 over the number of swaps each year. As this is a quarterly swap, the accrual period to unannualize the rates is therefore 1 over 4. And phew, we finally come to the end of this rather difficult lesson. As mentioned earlier, you shouldn't be too bogged down with the formulas and calculations. Rather, understand the underlying concepts of the derivatives and know the appropriate figures to be applied to the Black model. We shall move on to option Greeks in the next lesson. See you again.